Hi, Joe Cerrone, CAD 107. With this recording, I'm going to go through the first lab. Lab is located under content. And we're going to print this PPE. Yesterday, I logged onto the computer and I made a short video. There's a video tutorial of the COVID shield. And Daniel Lawrence is an instructor in the engineering department who was just really very proactive in helping people get this PPE. And so some of the schools were doing it and we joined in and we printed about, it was over 1,000 of these for emergency responders. And it's a really nice design. And so we'll be printing our own. And I have a video here that shows you how that works. And so if I click on that, so Al and I just worked on this one myself. I'll go through and I'll talk a little bit about the 3D 45s and the material, how to bring it into AutoCAD, and just some basic navigational tools for AutoCAD, how to save it as an STL, and then how to open it in the slicer. And you can see, do I print it this way? Is this how it's supposed to be? Well, as we go through the theory in the textbook, what you'll find is that in additive manufacturing, sorry, it's making me dizzy there, it'll print one little line at a time. And so we'll go through and we'll use something called a slicer. And so as we put this onto the build plate, I'll show you how to set it up so that you can slice it. And then we can see these different layers here. And then we'll go through a number of the settings for that. So there's one video for that already. And then I was able to hook into my home computer, which I'm networked with. And here it goes through and touches off and makes sure the build plate is level with these sensors. And then I kind of ended the video a little bit soon. Whoops, I'm not sure what happened there, but let me just go back. See all my playlists. So that's lab one. And then as we look at the lecture material, let's take a look at that. And so I think I'll change the name here. It's the same one. Me and him are turning into, well, I won't say it. So welcome to 3D printing. Here's our textbook. Again, we go through the software. Al's terrific with AutoCAD. Here's the Dremel slicing software. And we'll be using these Dremel 3D printers. We put some interesting YouTube videos in. They use something called Octoprint. And I had a student set this up. It's really cool, but it allows you to speed through the builds like this. And so it's kind of fun to be able to, what it does is it takes a picture, every layer, moves the head, takes a picture. So it's a very slow process. A print like this probably took 4 or 5 hours, but you wouldn't know it by watching these videos. The 3D 45 features, I'm going to download this, make it bigger. That's better. So the 3D 45 is a really nice printer, and we started using them when a Oakton alumni came to one of our advisory board meetings, and he basically said he works up the block in Mount Prospect at the Bosch Dremel factory, and he said he wants one of these in every one of the schools, and I said, sounds great to me. And so we went into it quite big. We have a lot of them. And so right behind me, I have 6 of them. And basically they're fully enclosed, which is nice because if you have little kids or something around, it's not a real dangerous machine, but yet on the other hand, you don't want people putting their hands in it. It has an Rfid reader, which will read the material and set the properties for the material to be printed. The heat for the nozzles, the extrusion rates, the build plate, how big a part can I print? 10 inches by 6 inches by 6.7. And so this is our build platform. It has this LCD screen. The LCD screen is okay, not bad. You kind of have to hold your finger on the button a little bit. You know, you can't just push it real quick like on a good cell phone. It's got a nice extruder. Build resolution is good. Wi-Fi and Ethernet. This is the way to go. Your 3D printers now all have apps, and you can run them on your phone. And so we have some Ultimakers here also, which are dual extrusion, and you can just run them from your phone, and you can have the phone there on your desk, and then you can monitor the build so that if it's done, you'll know, or if it's starting to glitch out on you, you can see it. It also has a USB port, which is very helpful because you can just save your file to USB and then walk it over. You don't have to rely on the technology of the internet. So as we look at 3D printers, when I first saw them, we bought and we didn't buy it. It was the Footlick. The Footlicks have been a very generous component at Oakton. And after the graduation, one of my coworkers and I were invited over to his house, their house, and they said, you know, we'd like to help you guys out over there. And we're sitting in his kitchen overlooking the pool, and he wrote us a check for our first 3D printer, which was a Stratus Dimension, and got everything started. It's been a really terrific machine. They cost about $30,000 at the time, maybe a little bit more, and this was around $2,000. Nowadays, you can get them for a lot less, but with that, learning how to print with them takes a little bit of time. And so you can get a number of different types of files from printers or from different sources, which we'll talk about. It's a manufacturing technique. It's not a printer. It's a CNC machine, essentially. Okay, CNC meaning computer controlled machine, because it runs on what's called G codes. And so I grew up in the shop, 13 years old in the metal shop. And so as I, worked in the shop, I was familiar with how to make things, and it's a very similar process. And so it's, you can call it a printer, but it's really a CNC machine that runs on G code and extrudes this plastic one layer at a time. The history, here's our founding guy, Chuck Hull. He's 82 now, because my dad's 81, and he was born in 1940. And it gives you the history on how the technology came about. Kits versus assemble. We always have students who want to make their own, and it's tricky. So be careful. Most of the guys like the Prusa 3D printer, and it's an excellent printer. And I think you can buy the Prusa, let's see here. Not bad, $750. They have some different sizes of them. If you go into shopping, and usually that's for the kit, and then they're probably going to charge you another $150 to have it assembled. And when you get down to it, you kind of go, well, I know my skill level, and that's kind of where you want to be with it. I've done a lot of projects around the house that maybe I should have hired somebody to do. I'm good with some things, but other things, you want to know your level with those things. And there we go. And let's see, where was I at? There we go. 3D printers, this is what's really cool about it, is that you can make things that you can't make any other way, provided that you're working with a water-soluble material. And so you need a dual extrusion 3D printer for that. These are not dual extrusion, the Dremels are not, but we do have dual extrusion 3D printers. And so the Stratus Dimension prints in ABS, and that has a support layer and a print layer, and it has a special tank and a chemical mix that will remove the material, because as the printer prints, it can't print in just mid-air. It has to have something to build on. But what's really neat is that you can remove the material by putting it in a solution bath. And then you have these things that are just like a kind of like a ship in a bottle. How did you get that into it? We also have a laser cutter and some CNC machines. So they talk a little bit about these. Laser cutters, the really cool thing about them is the materials are super inexpensive. You can make stuff out of cardboard. You can make stuff out of old plywood. You can make stuff out of plastic, and it just cuts it, you know, and it's quick and it's clean, and it doesn't require a whole bunch of setup work. And so I forget what the name of the one is that it's on TV. I was going to say Forge, but that's not it. But, you know, people are starting to put these things into their houses as well. This is kind of the area that pays the highest, these CNC machines. You know, having a good knowledge of manufacturing, these are everywhere. And so that's a CAD CAM type of system. It's actually a CAM system. And then as we look at these, we'll get familiar with the file types for 3D printer. STL, stereolithography, and G codes are the files that we'll use to run the printers. And then CAD, these DXF files, drawing exchange formats. I'm not sure what SVG is. And then the CNC.
Scalable vector graphic.
Thanks, Michael. What's it called?
Scalable vector graphic.
Very good.
They're used a lot on websites.
And then as we look at it, you can see G code and G code. So they're really running kind of the same. And then, you know, these run on CAD that's converted. And I wouldn't be surprised if it's G codes on the laser. I'll have to go through and read my manual. So the thing about 3D printers is they're not as fast as laser cutters and CNC. So when you're building something and somebody says, oh, you know, I need a 4-inch by 2-inch plate, I'm gonna 3D print it. It's like, just go take a piece of wood and cut it, because I can cut that piece traditionally in about 5 minutes, but if I'm going to print it, it's going to take 4 hours. Now, maybe you want something that's going to be special, but that's the speed aspect of prototyping. Laser cutters and CNC machines are very fast. Some of the questions, and you'll probably see these in some of the quizzes, you know, name some parts that you would make on a CNC machine or a 3D printer or a laser cutter. Talks a little bit about these different techniques. All right, let's make something. So that's our lecture. And then if we come up here to the lab 1. I already made the video for the COVID shield, so I'm going to try this one. So this is this device that's used to open doors and to be able to be hands-free as you're walking around. Give it to your mom; she'll probably like it, because I know my mom doesn't like to touch anything. As we go through and we work with this, we're going to give you the CAD files. And so if you're a SolidWorks person, we've got that here. This is for the face shield. Dan did this on SolidWorks. This is the door, and I got this off of Thingiverse. And what you would do is you would download that, and then you would open that. Now, it would probably link to 3D Builder on mine, so I'm going to just go here to my area of the Dremel 3D Builder, and I'm going to maximize that. And then I'm going to just delete it and see if I can then open it. Do a save as. I think I've already got it there. I do, so I don't need to. So this is the Dremel DigiSoft software. I'm not sure why they call it DigiSoft, but and as you work with it, this is the build volume. It's a little wonky with the mouse as far as to get the buttons, because you start working with AutoCAD, then you work with SolidWorks, then you work with this, and they all have the buttons slightly different. But if you turn the wheel on the mouse, it increases the zoom level. File, open. I'll get this file that I just downloaded. And it comes in no problem. And this is nice because somebody's already engineered everything the way we want it. And that's the nice thing about working with professional websites on it. And so this is our door opener. And as I work with it, I can choose the materials. First off, I can choose the machine. And what I'm in the process of doing is networking them to my laptop, because my IT department doesn't want us to be on the internet, and I can't quite understand it. It's sort of like a laptop. But the idea is you can manage all these printers from a central printer. And so you have I have what I call a 6-pack of printers. So I'll have 6 of them on the shelf behind me, and I'll show you those if I can start my video. And then let's go and choose my source. And so I have one of the printers kind of set up and ready to go. I'm not sure if I'll be able to get it to print in time, depending on if we segue into something else. But as you can see, it's right over here, and the door opens like this. You can work on the LCD. It has a top that opens, and we put the build material here. We thread it through this tube into the top here. And then we put a build plate on, and I'm going to put some glue onto this build plate. So as we work with glue and putting it onto the build plate, you just want to put a layer of it in the area that's going to build on, just like that. And it clamps in here like that. And then we can close this, and then we can close this. I'm using PLA in here, which has a tendency to absorb moisture. So you have to be careful about how long you leave it out for. And typically what I'll do is I'll purge the filament and make sure that I get it running really well. I purged it on a couple of the other machines over here. And if I take and look at it, you can see in this orange one, and then if I click on that, and so that's a good way to see if it's running and it's working correctly. You can see it's got kind of a, there it goes, it kind of comes out. See if I can get my cam set back. Oh, not too bad. All right, back to work.
Oh, Joe,
Yes, sir. I mean,
what
great.
happens, what are the problems that occur when your filament is, I guess, wet?
It bubbles when it comes out of the extruder. You'll actually see, like, the guys that work with me are really very into the details. And so you'll see little bubbles. It won't give you a real strong, clean build line.
Okay. Yeah, I'll say that one of the biggest challenges I've experienced in my limited use of my printer is getting the to stick to the build plate.
It's exactly
I've
right.
tried, masking tape and glue, and I feel like there's something else I tried, and it is a heated plate. I've tried adjusting the temperature and things too. So I wonder if it has any, do you know if there's anything about having the filament like not dried that causes it not to stick well?
There's all kinds of issues with filament, and we'll get some, and it just doesn't print real well. And I'll get the guys, they'll leave stuff out whenever it doesn't work. They like to tell me, and so they'll leave it on my desk, and it'll look like a bird's nest or something, and they go, "What's wrong with it?" And sometimes I'll know, other times I'll just tell them contact tech support on it. Yeah, build plates, and sometimes what happens is if you have a really big part, it starts to lift off as it cools, or as the heat is concentrated on different areas of it. All right, so we're going to build this part, and what I'm going to do is I'm going to make another video so that these don't wind up being really long. So I'm going to stop this recording. We'll call this lab 1 part. It's actually really part 2 because I did one yesterday. I'm going to stop the recording and we'll make another one.